Why is space dark if there are billions of stars? Every night, we look up and see a mostly black sky. But that doesn't make sense. Scientists estimate there are hundreds of billions of galaxies in the observable universe. Each galaxy contains hundreds of billions of stars. That's more stars than you could ever imagine. So here's the question. If the universe is filled with stars, why is space so dark? You might think the answer is simple, that the stars are just too far away. But that isn't the whole story. In fact, if the universe worked the way people once believed, the entire night sky should be glowing with light, almost as brightly as the surface of the sun. So why isn't it? Imagine you're standing in the middle of a massive forest. No matter which direction you look, your line of sight eventually ends at a tree. Now replace every tree with a star. If the universe were infinite, had existed forever, and stars were spread throughout it evenly, then every direction you looked would eventually end at a star. That means the entire sky should be bright. It would look like a continuous wall of light. This puzzle became known as Olbers Paradox, and for centuries, scientists couldn't fully explain it. So what changed? Our understanding of the universe itself. The first piece of the answer is that the universe is not infinitely old. Today, scientists estimate the universe began about 13.8 billion years ago. And because light doesn't travel instantly, even though it moves at nearly 300,000 kilometers per second, it still takes time to cross space. Even the light from the moon takes about 1.3 seconds to reach Earth, and the light from the sun takes about 8 minutes. The nearest star beyond the sun, over 4 years. Some galaxies are so far away that their light has been traveling toward us for billions of years. And many regions of the universe are even farther away. Their light simply hasn't had enough time to reach Earth yet. We're only able to see the portion of the universe whose light has had time to arrive. But that still isn't the whole story. The universe isn't just expanding. The space between galaxies is expanding too. As light travels through this expanding space, its wavelength gets stretched. Imagine drawing evenly spaced lines on a rubber band. Now stretch the rubber band. The lines spread farther apart. Light behaves in a similar way. As its wavelength stretches, visible light gradually shifts into infrared, then microwaves, and eventually radio waves. This process is called redshift. That means many distant galaxies are still sending us light. It's just no longer visible to the human eye. So even though those galaxies are out there, they don't brighten our night sky because our eyes simply can't detect most of the light they emit. Here's the surprising part. Space isn't actually dark. It's filled with radiation. One of the most important examples is the cosmic microwave background, the faint afterglow left over from the Big Bang. It fills the entire universe in every direction. If our eyes could see microwave radiation instead of only visible light, the sky would never appear black. Instead, we'd see a faint glow surrounding us everywhere we looked. The darkness we see isn't because the universe is empty. It's because human vision detects only a tiny portion of the electromagnetic spectrum. So why is space dark? Not because there aren't enough stars. It's because the universe has a finite age. Light takes time to travel. The universe is expanding, and much of the light that fills space has been stretched beyond what our eyes can see. In other words, the darkness of the night sky isn't a mystery anymore. It's actually evidence that reveals some of the universe's most fundamental properties. The next time you look up at the night sky, remember this. You're not looking into empty darkness. You're looking into a universe that's still unfolding.